I have something to say about Michell and John Neal's work on metrology that relates to what I have ended up doing. Because the finding of historical metrology was scattered all over the empire-building world. And it isn't really without the persistence of John Michell, who partially solved some of this enigma, and then John Neal, who discovered an entire system based on relatively simple ratios. And this was used, obviously, as a calculational tool of great use in the ancient world, particularly, and probably in the later megalithic world, because it enabled you to work with distances around a circle or areas of squares, or to make it possible, for instance, to get over things like pi, which is a number that has no end if you saw the full number. It's a ratio that we call a big fraction. So the entire ancient world was founded on what we today call integers, which is a whole number, and the whole range of integers starts, of course, with 1, and then you get the other numbers, and they do very interesting things with each other. But today we don't have this consciousness with numbers. We use them as a continuum for which we just record events, account for things. So the subject of historical metrology turning into ancient metrology led me to realize that we had gone through 3 stages. An earlier stage that had developed the ancient metrology. And you wonder, how could they have done that unless they'd had a civilization that already existed before some deluge or something like this that was sort of known about by the megalithic people, and that's been quite a common theme. But we have to take into account how we've learned to change as human beings. We have definitely developed some new tricks. And one of the tricks around about the time of Greece was to think abstractly about problems. And in the ancient Near East, which is what we call, Babylon, the Sumerians, and Egypt, their scribal schools generally did mathematics more like we would do mathematics at school in an early stage of saying, how many people do you need if so many people can lay a brick? How many people do you need in so many hours to make an entire building? So these sort of applied problems were the realm of the ancient world, which also had an ancient metrology, and those scribes used it. And it was full of all of these clever ratios initially for calculating things. So I thought, well, I was on holiday in Crete, and I thought, I have nothing with me. And when I started thinking about it, I thought, well, how did ancient metrology really come into existence? And I think the clues lie in some of the work of my brother, who had these triangles that had units of a particular yard in them called a megalithic yard. And they all have its integer relationships over 19 years between the sun and the moon. And the question is, how did that system, if it existed, how did it come into existence before that? What's the natural process? So I believe that my work has been one of looking at how the time periods of astronomy, which are the things that are still out there if we really chose to look at them that way, but today, because we have our instruments, we don't measure time in terms of individually each of us counting it. Well, you might do in a sacred calendar or something, but indeed our culture is now one where we don't have really very much connection at all with the outdoors, most of us, and with time periods. These are not really very significant. But I believe that the time periods became the monuments, and that to do that there were techniques and insights along the way. And so that they form the intermediate, and it's discovering what those are that I will be talking about. The single initial technique, which we see that connects the megalithic to the late Stone Age, it preceded the megalithic by 10,000 years or more. And it was counting days of lunar visibility on a bone. The bone could be off a midden, and a person counts for their own sake. They're doing this for themselves. And they make this count and they say when it's visible and when it's not. And so this changes our perception away from the idea that of the familiar cave paintings, these people were already extreme overperformers from our point of view in art and visualization. But less familiar is their use they made of bones to make these repetitive marks, which are similar to counts or even like numbers are today. And this would indicate that numeracy, before the ancient world, had developed from something that was pre-numerate, where numbers were held in lengths. So here's a device I'll show you later a little bit, but it's called an inchometer. And this shows how there are numbers of things here which are inches. And we'll see how the Stone Age is a natural transition to the megalithic period. So the gentleman who realized this was writing a book on man's relationship with the moon. And here he is, he's called Alexander Marshak. And during his research, he discovered that the marks appeared to be time factored. So here we have 2 months shown in a series of marks. I'm not going to interpret it now, but here is a slightly younger bone, and this one was found in the Belgian Congo, and one can see the groups of stones, and people have thought that these were perhaps numbers that were being worked on. And then this is the final thing that he found that was of greatest interest, which was a count for 3 lunar years and 3 solar years. It wasn't completed, or it may have been damaged. But you can see that the marks down the far right-hand side, they are descending. And his interpretation after 10 years of work was that these correspond to deviations required in order to track the solstice on years. So there was this discovery and perception of the twin relationships of having the lunar moon, the moon rather, and having the sun, which of course has become an agricultural calendar later than that. First of all, I just say that they're structured in subsets of 29 to 32, because a lunar month is about, well, it is 29 and a half days long. So that will be a number that comes up and perhaps haunts us later. And in this, he makes the remark, and this has been very well buried, this remark, that there was an indigenous European observational astronomy in the megalithic, and it appears derived from the Paleolithic exercises that were going on in caves that are not a great distance from where we find in Brittany the monuments of Karnak. And so the megalithic counting is an interest in time periods caused by an innovation of using fixed lengths. Instead of just marks, and you don't even bother to count them, they're just a sort of like a load of marks. If you have fixed spaces, then suddenly you've immediately invented the beginnings, in a sense, of metrology, which is you are controlling how you use measure. Gave birth to this discipline, perhaps, and the ancient metrology of the megalithic and ancient world is clearly descended from the counting lengths of time, in my view, in inches, which then used aggregates which involved feet and megalithic yards and cubits, but then this was reframed to become more powerful later on in the megalithic. And so there was an earlier phase to the megalithic, and that's what I am, in a sense, proposing, and I propose in the book. And this is demonstrated best at Lemanio in Karnak. So on the right is when we did our survey. This is Robin and me. You know, Robin Heath preceded me in the area of writing on the megaliths, and he found the most perfect example of a megalithic structure that confirmed his theory about a particular triangle that connects the sun to the moon. And Lemanio, there is a large jante, and I can't move apparently because of the microphone. So, but the jante is down here, and there's another stone, but that's flat on the surface, and they found a square stone here, and these are 3, 4, 5 triangles following the summer sunrise and sunset and the winter sunset if you go down there. So that's capable of measuring the length of the solar year. And then on top of here there's something called a quadrilateral, a monument completely unique, I think, in the entire history of any monuments that we know of. And it's a bit like a long rectangle, and it appears to have stuff going on in it, which I'll tell you about. And this is going to be to do with the relationship between one lunar month difference between the two types of year. There's 1 year, the solar year, is got this 1 lunar month difference over 3 of them to 3 lunar years. So you get 36 to 37. It's just slightly over that, and this is symbolically very important, because here we see the movement between along the southern curb of this monument. We're looking, unfortunately this is in a different order, but they started counting at this point P, and came to this point here, or at least this is what they symbolized for the activity of counting, so that you get the same number of days, inches, as you do days in 3 lunar years. And to this point, on stone 37, you get the length in days, but in inches, of the 3 solar years. And that's what's going on from the sun gate there to here. And there is the jante. And well, I've said it there on the slide. So we go on to what this really means, for instance, about the original proposal of a lunation triangle, which was measured in yards being months. That's down there. And you get the solar year at the top, on the top angle. And then the one on the flat, that's the lunar year, up to the point where there's 1 over, and that's exactly 1 foot, in the way that Robin was measuring it. So in here, what we find is the same angle, so it's the angle that's important. It tells you that 14 degrees is an invariant ratio between the solar year and its length and the lunar year and its length. And then, in the process of doing the survey, we saw for the first time that the base is 12 and the side is 3. So it's a 4 square rectangle. And this was very important because of work that was already going on in Karnak with Howard Crowhurst, who I believe has spoken here. And he has worked with multiple squares and the way that they nest together in a very interesting fashion at Karnak in the monuments. The work of Howard Crowhurst demonstrates the alignments to the sun and the moon at Karnak only. So why did these megalithic people settle to work at Karnak? And in that age, they had the most miraculous set of conditions which enabled you to more or less find out where the sun, at its extreme point in the year, would be on the horizons, looking east or west at sunrise or sunset. And then they also discovered, so I've done all that as well. So what's happened is that the work with Robin has allowed time to be added to the idea of space in a set of consecutive squares. So in the squares at Karnak, we have the lunar maximum. If you're looking east, the lunar maximum in the northeast would be at 45 degrees, a single square. And this double square shows you the lunar minimum. Now these are separated by 9 and a third years, those 2 points. So that if you live somewhere, you see that the moon keeps coming up, and it sort of gets wider. Every day it comes up like that, then it marches backwards again, and it goes that way and goes backwards, and it sort of goes like this over an 18-year cycle. And this is very important because it's a very, very small number of years within which that happens. Relatively speaking, 18 years. So this shows that at any site you can go there and you can lay out the site, and you know before you actually put monuments in place where everything is going to turn up on the horizon. And this is Howard Crowhurst's map from this 2007 book called Megaliths in French, which shows the interrelationship of a lot of sites that are basically interconnecting modules like that. So every site over many miles formed a network. So the multiple squares work like this. They can stack up, as we see here, those two triple squares. Now, a triple square is also an astronomical approximation to the solar year and the eclipse year. Don't worry if you don't know what an eclipse year is, but it is something that does allow you to predict how long there will be between possible eclipses. And this also gives you a relationship between the solar year on the bottom to 13 lunar months, another type of lunar year. And here we see two triple squares stacked up allow you to get the midsummer solstice, a 3-4-5 triangle at Karnak. And when I looked at the monuments of the AAK, which is a group that Howard used to belong to, they have French magazines of about 1980 vintage, you find that these are all stacked up in their monuments, although they didn't really highlight that fact. And I think that, you know, it's sort of come to light more recently. And so here you can stack up a 3-4-5 triangle, and you can use another thing called a sevenfold square, and you come to the 45-degree lunar maximum standstill. So that's a time relationship, and you can see between the triple and the 4 square, a 13 square is the angular difference of the diagonal. So it's the angular difference of these diagonals to their baseline that are stacking up and producing this peculiar miracle at that particular latitude in Karnak. And we'll just have a look at these now. So in the quadrilateral, in fact, the longer I worked on it, and this was after 2010, I began to see more and more inner detail inside it. Here is the normal triangle of the lunation triangle, only it's in day inches. But you can superimpose these other square shapes and rectangles, and you get 3 eclipse years, 3 lunar years, 3 solar years, and 3 13-month lunar years, all in a monument. And the notch, this picture which I opened with the view from the notch, you can see goes right past the stone 37 at the end. And then this is a sensational chambered monument called Manet Ruthal, and it has used a 4 square on the diagonal, and then added to that, it's managed to stack up a, well, you've got a square, a double square there, and because of these relationships of putting the triple there, it's pointing to the lunar minimum here and the lunar maximum. So I want to point out that the form of the monuments is a representation of the reality of astronomical time, as if one could materialize it and see it. And this is a way of turning the megalithic monuments out of being buildings into being higher representations of a world that's in the sky. And the reason why they're as long as they are, or they're the shape that they are, is because some of them include things like counting and also long alignments. And so when it includes counting, the counting has to be so long. And if, for instance, you're counting in inches, then if you count, for instance, in 19 years, that's a pretty long count. And if you are counting in feet, it would be even longer. So the solution, perhaps, to why the monuments are the shape and form that they are, in Karnak seems particularly clearly that that's the size and the shape that they had to be from their point of view. And then you can use geometry to transform counting. So here I've shown that you can count, as we are at Lemanio, you can count from there to there. And then in Lemanio, you count a longer thing and compare it with a shorter thing, but in the same range. But you can also do this. You can count backwards and forwards in the same line, so that, for instance, when you have a lunar maximum, you can start counting in this direction, and after a certain number, you will be able to, you'll get the minimum, and then you can turn around, and the same number will give you the maximum. And the number for the total sequence is, amazingly, an even number of days. It's 6,800 days between one lunar maximum and another, and half of that is 3,400 days. So 6,800, 3,400 would allow you to count across. And another technique is, of course, you can count round like this. If you can arrange to have the circumference an exact number, then you can go round and round. And these two things are re-entrant. So you could go on forever going backwards and forwards or round and round with them. And so when these things are put side by side to an alignment that shows the maximum or the minimum, then it's not like, as was said with Alexander Thom, Magnus Magnusson said to him on a BBC programme, but what if they miss it? What if they miss the event? You know, will they, oh, well, I'll just have to wait. It's not like that, because they've got so much stuff going on with their counting, so many things they're observing, and so many processes that they've got a handle on by having the counting process, that that these were fully active observatories that we're looking at. And the next thing you do with counting that you can do is, because the moon has an orbital period of 27 1/3 days. It's shorter than the lunar month, because the lunar month is a result of the orbit and the sun's light on it when the sun's moving. So if you multiply that by 3, you get 82. And when we were at Karnak, right at the end, we had a very strange event with a group in which it became obvious that these were important stones, even though they were in the walkway. And this illustrates the problem with the megalithic, that if you don't understand about metrology, and if you don't see what might be going on, then something very precious could be being treated just as something underfoot and maybe removed to make a tarmac path. So people have stumbled over this for many years, and they are equally spaced by 17 inches. And there are only that many of them, but if you were to continue them on, you'd be able to count around by moving the moon by 3 stones every period. And there's only 2 numbers that work well for doing this job with the moon, and the other one is what Fred Hoyle said was the use for the Aubrey circle, which was to count using a simulator again of the sun and the moon, from which you could study the moon's nodes and eclipses. And so this is another thing you can do with counting once the technology and the techniques and the insights have reached a certain stage. And this means that they became very competent astronomers, even though they were using a very weak form of astronomy that we call it horizon astronomy. Right? So if you can only measure to things that are happening on the horizon, then that's a weak point, because the sun, the Earth's rotating all the time. There's lots of motions that are nothing to do with the things that you're trying to measure, which is the sun and the moon. But if you are able to simulate the sun or the moon using a count, so the combination of horizon events, counting and simulation radically transformed what megalithic astronomy could achieve, because ecliptic astronomy removed the confusing mixture of celestial movements and the yearly orbit and the rotation of the Earth to reveal the sun and the moon moving through the stars, which is exactly how we see the zodiac. And so if you're running a simulator, then you know you start to learn when the moon's there that those stars are there, and so forth. And when the sun's just rising, you know that the stars that are just before it, visible, that they're there. So you are, again, intensifying the experience of astronomy that was available without inventing any kind of what we call modern mathematics or instruments. And then the next thing they could have done with circumpolar counting is circumpolar counting, because up in the sky we have effectively a great big clock. It turns once every sidereal day, so just slightly less than a day. It's exactly what's in every observatory on this planet at the moment, but they're all mechanical clocks. But by seeing this, as you look directly, you can see that it's marked off by our system into 12, just like our hours. And again, you would know that if there's a star rising coming up to there, then you know what's rising on the horizon over there, and you know what's going down over there. So the idea of using the circumpolar counting, I was driven to discover this because I couldn't explain what the alignments were at Lamennec without knowing that they had some means of knowing where the sun would come up if it was at the position where the moon was on their simulator. Because if it doesn't come up at exactly the right time, then the moon must be sitting above or below the sun. And these things are very important for them. We must realize that they have no idea what they're dealing with until they can understand it. And we are spoilt because we know so many different things that are given to us on a plate. For them, the world was completely filled with mysteries to do with the sky. But for us, there's books on it, there's documentaries, but also the weather, biology, everything we know. But have we really earned it? Well, they were earning the first understanding of these things, in my view, and they were able to do it with this sort of technique of looking north. So time could be quantified below the level of the day. And that's quite important, because a day is sort of quite a crude measure, really. But you can still use inches to represent things around the outside of a circle. And let's see what I've... This shows that the moon may come up early or late if it's not sitting on a node. So the sun's going along in the sky like that, and if the moon crosses it, because it moves more quickly, if it crosses in its orbit, because it has a different orbital path, then at the node there could be eclipses. But where are these nodes? And this becomes a really interesting story for them to find out. So rising late, they learn from the simulator that how to find out where the moon exactly is. And the circumpolar counting, you see that the form of the observatory now is like this. It's looking north, and a lot of people don't even look north really very much for their when they're analysing or looking at a megalithic monument. And it's also looking south, like that. And it's looking towards a stone which marks the summer solstice in the middle of the alignment. And this is the 3-4-5 triangle that we were looking at before, that's part of this sequence of miraculous geometry that was available at Karnak at that time. And then here is a circle from which you would make what's called a type 1 egg of Alexander Thom. And so it's been extended. An egg is bigger than a circle. And at this point, one starts to see that the units of length are meaningful, that the circle is 2 times 365 feet around the outside. And this means that every day starts 2 feet later on this clock. If you were to monitor the circumpolar stars, then this performs the function of counting to realize that on a particular day, the sun rises. If this was the Earth, they're starting to develop the picture of the Earth, because that's the Earth rotating right there. And if I'm here at this point, one day, and the sun is rising and the sun's over there, the sun's moved down here, then that means it's moved on. So it would have moved on 2 feet. But even more miraculous is that the scale of that circle is related to this outer perimeter by the fact it's 1,000 inches long. And the amount of time that the sun moves on every day when you're on Earth, 1,000 of those units of time make up the orbit of the moon. 10,000 of those. So the unit of 10,000, which started in my first book, a lot of these things start to pay off, that you discover a monument that expresses it perfectly. And so they're simulating the moon. So the moon's orbit would go once completely round there, whilst the circumpolar sky is being tracked around here. And so it's as nice as a Swiss action wristwatch or something. It's got that beautiful property of the watchmaker's art, but it's a form taken and done with great skill, because they've discovered that they can use that forming circle and then have those 10,000 inches as an extension of it. So I want to show you some pictures now, which are largely from Gavrinis, actually. So Gavrinis, there's the monument I was talking about, Lemanio. Here are the alignments I was just talking about. That's all these stone rows that are the most famous thing in Karnak. And 4 kilometers over here, there's Karnak's many monuments have eventually produced an island full of unique engraved stones. And this was towards the end, about 3,500 BC. So this monument here, we're talking probably about 4,000 to 4,500 BC. But by this time, they're starting to come to the end of the time of building the megaliths there. And in this is a chamber that you enter, and a massive cairn that looks almost like a pyramid. And my theory is that these things are information boards to do with information time, astronomical time, and inches. Because many of these monuments can be read with the knowledge of metrology at the simplest level, but it also indicates to later metrology in a very special way. So the engravings are weathered as if they were in place at a particular monument. And I believe they're a form of pre-literate technical art, that the technique that they had developed was being turned into art, probably paintings originally, and then eventually they would be tapped into engravings on this special stone. And so there's one we will look at, R8, and there's L9, which we won't be looking at, but you can see there are various different, but they're quite similar, the types of things that they're doing in them. So Lemanio, I believe, L6, this is L6. Now this work has been done quite recently by Nantes University, and Laurent Lescope there in the Department of Architecture originally let me have a look at some of his pictures, and that's led to a long conversation over the years, and eventually he didn't mind me talking about them in my book. So you'll see some of this in my book. So there's elements of it that I've read, and it's a bit too much, for us to consider it all here, but basically you've got 3 years of counting going on. You've got a measuring stick. You get a measuring stick here, which is 29.5 days long, which is the lunar month. And I believe these are the 3 years. And this year here is slightly thicker because I think they thought of them as a 12-month year, and then a 13-month year. And between there and that point marks the Megalithic Yard. And it's the Megalithic Yard, when you do a 3-year count, emerges as a difference between the sun and the moon. And I believe that this is the absolute origination of the Megalithic Yard in its original form. Obviously things have changed over time for various different reasons. So, and this is Gavinus R8. I've put this on my website, which is megalithicscience.org, not for profit. And here it is. The lower register, you often find these stones are in registers. So there's some sort of an idea they have for laying them out. This here we see, can you see on this one all right? Let's just, yeah, I can't. So what you see is a four square triangle, which represents, as you know, can represent a solar year across its diagonal. So as you go along here, you've got 1, 2, 3, 4, 5, 6, 7, 8, to 18, right? Now, after 18 years, if there's an eclipse at this point, then there'll be an almost identical eclipse 10 days or 11 days later. So at that point, they've marked a little distance, which is about 10.8, 10.9 day inches on the actual stone. And here we have the Saros. It doesn't say Saros on it normally. So the Serous Period, which is the one we use today, all eclipses that we have today belong to one of a number of Saros cycles. And they're almost identical because the conditions of the moon and the sun are almost identical with regard to the distance from the Earth. So that is, in my opinion, an explanation of that stone, that they are telling us, or telling people at a monument, something that they need to know, like an information board, to accompany that monument. And maybe the third thing is that somebody who knows about the monument and that will be there as well. So the upper register appears to show ratios of pi and the qubit of 12/7, and that's the foot down there. And you see that they're breaking up numbers into 3, 4, and 5 there, which adds up to 12. And there's also 7 up there. So there are things going on in that stone. And then the entire monument, this is from the original AAK drawing, which I've added to. The Gavridis design, you can see, is a multiple square design. Is designed to look at the maximum moon in the southeast, directly down the chamber, so that the light will come onto the end 2 stones, and it's stoppered there and there, so that you get the extreme sun just coming down. And as you can see from the multiple square sort of picture, you end up with a 7 square relating a 3, 4, 5 to the 45-degree angle of the lunar maximum. So there we see a picture that was taken in 2004, and down here is a foot which has 7 units. 1, 2, 3, 4, 5, 6, and 7. So make that into a circle, a radius like that, then you get another 5 up here. 5. And then here, around the outside, appears to have been the extent of the 19/7, which is effectively the astronomical Megalithic Yard. This was done by a friend of mine, but all these pictures are from originals by this group, which include 2 archaeologists, Serge Cassian, and I don't know Grimard's first name, and there's Laskop. So I want to be quite clear about that. You know, these are not pictures that are generally available or that I produced. So there are long counts. So I'll just show you that there were some long counts also detected in an amazing way in Lemenek. 34,000 megalithic inches. There are 40 megalithic inches in a yard, and 100 in a rod. Well, it's called a rod by some people. So along here is 3,400. So you can count backwards and forwards as long as you like and track the maximum and minimum doing that. But at the same time, I discovered that this length here, which is the radius of the circle that's used for the circumpolar astronomy, is also 47 lunar months long, or which is called an octad in people who know about these things. And would you believe it, in normal inches, it's 4 eclipse years. So that's another example. In that monument, they seem to have an amazing parallelism, an ability to find the thing that combines so many different aspects to what they look for. And here's, the picture of the 2 sort of mounds either side, and they're on the Aubrey circle. And as my brother pointed out, they're very near. The Aubrey circle is very near to being 34,000 inches across. 3,400, sorry. Doesn't make much difference, I suppose, but there we are. Go backwards and forwards. You can again track the lunar maximum and lunar minimum. So I won't go on too long, but what does this prove? It's become obvious that the counting of lengths is a missing partner in megalithic monuments. And geometry is then the third factor, leading to the form of monumental architecture that we call megalithic, at least at the early phase. Out of this came an art of representing astronomical relationships and of numerate thought in paint and engraving. But in Britain, very little of these have survived. And they're usually in very bad condition, so you can't really say much about them. We know now that the history of numeracy, I think, is much deeper than people will allow it to be regarding beyond the ancient world. And so the monuments of the British Isles, Sumeria and Egypt involve an ancient metrology, which is an applied mathematics. But the early metrology came from the megalithic, typified by Carnac at least, in Brittany and France. And then counted tallies existed, and what they did with them is very difficult to work out, but probably as the lunar month. Understanding counting makes monuments readable to ordinary people. So you can go along and you can actually make a measurement. I mean, it's not really totally simple, but it is something that's eminently doable, and it's a new way of relating to monuments that involves counting time, particularly. So looking for counting is a way of interacting. Tools such as Google Earth allow you to just try a possible insight, that you might have had for early, ancient or historical metrology, and it can tell us, to a certain degree, what the ancients were up to, which, after all, is the theme of this particular meeting. We know that intelligence can only emerge from some form of participation in which a change of mind is possible. Intelligence can't operate, and it can't be, if it has any opinion of any sort, it's not going to have any opinion about you if you're not really putting yourself to say, I want to change what I think about these monuments. And I think that you can't consult other people. Ultimately, it comes down to what you can think about these monuments. And this is a tool that they apparently used. And so it's a very good one for looking at monuments. And I don't say it's the only way that they related to them.